Salts in solution. In chemistry, a salt is a compound that dissociates very easily into oppositely charged ions when placed in a solution. For example, NaCl, or table salt, dissociates into Na+ cations and Cl- anions in solution. Although salts are neutral when they are not in solution, their dissociation can form different types of solutions, such as acids and bases. The decomposition reaction, or salt dissociation, can contain spectator ions. These ions are highly stable in solution, so they do not participate in the reaction, and they do not influence the nature of the solution. Here are some spectator ions to remember. This could help you identify more easily the nature of the solution formed by a salt dissociation. The right answer to this question is the salt B, NaNO2. Before explaining why the salt is basic in solution, let's start by analyzing the dissociation of the other salts. The salt A will undergo the following dissociation. The NO3- ion is part of the list of spectator ions presented earlier. We then concentrate on the NH4+. Remember that we're talking about salts in aqueous solutions, so if we let that salt interact with water molecules, it will lose a proton to get rid of its positive charge and form NH3 and H3O+. Since NH4+ loses a proton and H3O+ is formed, we are in the presence of an acid. The salt C is considered as a neutral salt in solution. This is explained by the fact that it dissociates into Mg2+ and Cl- ions. These ions will not react with any other compound. They're both spectator ions and allow the solution to remain neutral. The salt D will make an acid. In the same way as the first salt we looked at, it will dissociate into NH4+ and Cl- ions. In this case, the spectator ion is the Cl- anion. That means that it will be the NH4+ that will react again with the water molecule to form NH3 and H3O+, resulting in an acidic solution. Let's now examine the basic solution, NaNO2. The salt dissociation happens like this. There's the formation of sodium cations and NO2- anions. We might have a tendency to think that the Na+ ion would react with a water molecule to form NaOH, but be careful. Na+ is a spectator ion. It will never react with any other compound or ion. It's then the NO2- that will react with a water molecule in the following way. The NO2- ion is fairly stable in solution. However, a few molecules will still act as a base and accept a proton. This willingness to act as a base comes from the fact that NO2- is the conjugate base of a weak acid. In comparison, the NO3- ion, the conjugate base of a strong acid like nitric acid, is an extremely weak base. In aqueous solutions, the nitrate ion will act as a spectator ion and refuse to accept a proton. This is why acids dissociate so easily. The product of their dissociation is incredibly stable. We can conclude that NO2- would accept a proton to form its conjugate acid, HNO2. So it takes a proton from the water molecule to form HNO2 and some OH-. A solution that contains free OH- ions is by definition a basic solution, so NaNO2 is the only salt that will form a basic solution.